So for today, I'm going to be taking you through the basics of how to differentiate and also how to integrate. So I'll take you through the notation of differentiating and integrating, how to do it, how to do more complicated questions, and some more exam style questions, okay? So to start off with, differentiate x squared. So for differentiation, there's a rule you always want to follow. Use it for every single differentiation question. So to start off with the notation first, when you differentiate something, so normally it'll be written out as y equals x squared, for example. So to write the differentiated form, or the derivative, you write it as dy over dx. So to differentiate, you would want to take the power of the number, which here is 2x squared, and times it by the coefficient. The coefficient is the number in front of the x. So as you can see right here, there isn't one, but you can write a 1 in front of it because 1 times x is still x. So take the power, 2, times by the coefficient, number in front, which is 2x, okay? So I'm going to write that here. Now next off, this one's the easier bit. Take the power and minus 1 from it. So 2 minus 1 is 1, x to the power of 1. You don't have to write the 1 because writing just x means the exact same thing. So differentiating x squared gives dy over dx equals 2x. So now for a more complicated question, we can do 6x cubed. So same thing, it'll most likely be written as y equals 6x cubed. So we're going to use our notation, dy over dx. We're going to take our power, which is 3, times by the coefficient, which gives us 18, and then you're going to take away 1 from the power, gives us 18x squared. Now, there's something called the second derivative, which would be written as d squared y over dx squared, which is basically, you differentiate this to get that, and then the second derivative, which with this notation, is the derivative of the first derivative. So, take this here, we've got 2 times the coefficient, 18, gives us 36, and then 2 minus 1 is x, and as we said earlier, you don't have to write x to the 1 because x means the same thing as x to the power of 1. So that would be how you would do the second derivative. So for a more complicated question, with more numbers in it, same thing, it would be written out as y equals 6x cubed, add 4x, add 3. So dy over dx equals, take the power, 3 times by the coefficient, 6 is 18, minus 1 from the power, x squared, add 4x, so there's an invisible 1 here because you don't have to write it, means the same thing, but 1 times 4, the coefficient, is still 4, and then when you minus 1 from here, you get x to the 0. So x to the 0, anything to the power of 0 equals 1, which means it would be 4 times 1, which is still 4. So here, the 3, you don't do anything with this because the x term is not in here. It just disappears when you do it. So for a more exam style question, find the equation of the line y equals 5x squared, add 3x, add 6. So this is a more exam style question, and it's one you commonly find how it's written in exams, maybe towards the start of the paper as an easier question. So the equation of the line, this is actually what differentiation is used for. So for example, if I had a graph with a curve on it that looked like this is x squared. When I differentiate it, this would give me, I could use the equation here to find the gradient at any point on this line. So I want the gradient at this point here. That equation will find it for me as long as I know the coordinates of that point. So let's differentiate it. dy over dx using our notation. Take the power times by 5. 2 times 5 is 10. Minus 1 from the power is x to the 1, which is just x. Add 3x. So as you can remember, to the power of 1, you can 3 times 1, add 3. X to the 0 is 1. And then 3 times 1 is still 3, and the 6 doesn't have the x term in it, so you just get rid of it. So now this equation right here would be used to find the gradient at any point along the graph of this here. Okay, so moving on to integration. So this is basically the opposite of differentiation, okay? So integrate to x. So our notation for this, when you're writing it out, would be this here. This weird looking fs thing. So what you do is you'd write that 2x dx. And that's how it would be given to you in exams. So then you would write equals. So when you integrate this, you will add 1 to the power. So obviously, power isn't shown here because it's just 1, but we add 1 to the power, which gives us 2x squared. And then we're going to divide using the power, take the power, divide the coefficient by the power. So 2 divided by 2 equals 1. You don't have to write that, you can just write x. So x squared. So that's integration, which is basically the reverse of differentiation. So there's two types of integration, definite and indefinite. So this one is indefinite because we have no parameters on our integral. So because it's indefinite, we're going to do add c, which is basically just meaning that there's a number there that we don't know. So like in differentiation, when we just get rid of this term, in integration, that term could exist, but we don't know because we don't have set parameters, okay? So you have to write add c to say that there could be one of these numbers here, okay? So from a complicated question, how it would be written in exam format would be this. Our integral sine fx 5x